So I'm going to give myself more space, and I recognize that I am in a right triangle where I know all of the measurements around that right triangle. That's this right triangle right here. If that's true, then when h is 1/2, what is w? I see similar triangles. I have a triangle here, and then I have the larger triangle. I know what w is for the larger triangle. I know what h is for the larger triangle. So I'm going to use similar triangles. And on the h side of things, small is to big as small is to big. When I cross multiply, I get root 3w equals 1/2. So w has to equal 1 over 2 root 3 when h equals 1/2. So there we are. I'm perfectly fine, by the way, with having a root in the denominator. That is the value that I would put in there for w. If I were to call this h, I would have h is to root 3 as w is to 1. So root 3 times w would equal h. If I put w in terms of h, that's 1 over root 3 times h. This is the relationship I'm going to have to use to find dw dt. So a very involved problem where I'm using a lot of geometry to find out what's going on. So let's go back to another color so we can keep up with this work. If I implicitly differentiate this relationship, because if this is the relationship between w and h, when I implicitly differentiate with respect to time, that has to be the relationship between dw dt and dh dt. So everywhere that there is a dw dt, I'm going to substitute this value in. And there we go. Now I have an equation in one unknown, and I'm down to algebra. So a lot of information going on there. I'm going to give myself some space. You can just keep this in your notes. I'm going to give myself some space here so that I can continue to work on this problem. So the algebra that goes along with this, 3 equals, when I distribute the 6 over that first term, I get 3 over root 3 dh dt, plus distributing the 6 through the second term, I get 3 over root 3 dh dt. So I have 2 of those. 2 3 root 3's, 3 over root 3 dh dt's. I could distribute it. That's 6 over root 3 dh dt has to equal 3. When I divide both sides by this term, I'm going to get 3 root 3 over 6 equals dh dt. That will simplify to root 3 over 2. So there's dh dt, and I'll write it on this side. dh dt equals root 3 over 2. The units we said would be feet per minute. The question said, how fast is the water level rising? The water level is rising at a rate of root 3 over 2 feet per minute. And we should use MIN, not to be confused with meter. So there we go. Same amount of words, it looks like, on just about every other related rates problem that we've used, but much more involved in all the geometric relationships, because we're not in a cone, we're not in a cylinder, we're not in a sphere or a circle. We're in something that is a little more geometrically complicated than the other related rates problems that we have seen. I will say this is time consuming. There's a lot of relationships going on here. I haven't seen too terribly many related rates problems that have complicated geometry. Not to say that you couldn't see something like this, but again, there's a lot of geometry for very little calculus payoff. So I want us to be able to critically think and problem solve our way through things, and that's why I'm showing you a related rates example like this. It is doable. The process is the same, but I really don't believe we would get something this geometrically involved on the actual AP test. I could be wrong, but I seriously doubt it. Let's work a third example. This is a little bit of a change on our right triangle related rates problems we've been working. A kite 100 feet above the ground. So let's say here's my kite, and I'm 100 feet above the ground. It is being blown away from the person holding the string. Here's my person. And it's being blown away, so it's being blown away from my person. It moves in a direction that is parallel to the ground at a rate of, so if it's parallel to the ground, I would call this x, I would call my rate dx dt, and that's 10 feet per second. That is in the positive direction of x. At what rate must the string be let out? Here's my string going up to my kite. At what rate must the string be let out? I am in a right triangle. I could call this S for string. I can call it H for hypotenuse. I can call it anything I want to. I'll call it H. I am in a right triangle. H makes sense to me, but I can call it whatever I want to. It's asking for at what rate must the string be let out. That means the string is increasing, so that should be a positive rate. When the length of the string already let out is 200 feet. And when this kite is moving, it's moving parallel to the ground. In other words, the vertical distance never changes. This is a constant value. Therefore, dy dt would be 0. So this is a little bit different. We're used to the legs of the right triangle changing and the hypotenuse remaining at one value. This is a little bit different. The relationship is still the Pythagorean theorem. Instead of putting a value in for h, I'm going to put my constant value in for y. I wouldn't have to. I can do that at any point. But I recognize that that is never changing, so I might as well go ahead and make it the constant that it is. So there's my relationship. I will do as I've always done before, implicitly differentiate with respect to t. Divide every term by 2. Remember, 0 divided by 2 is still 0. Now, plug in the values that I know or can find. I don't know what x is. I'll have to work that out. They tell me dx dt is 10. They tell me h is 200, and they want dh dt. So again, I'm going to go back to this relationship to find a value for x. X squared plus 100 squared would have to equal 200 squared when h equals 200. Give myself a little more space. X squared will have to equal 200 squared is 40,000. 100 squared is 1 and 4 zeros. So that would be minus 10,000. So x is going to have to be the square root of 30,000, which is underneath that root 3 times 10,000. So a 100 gets to come out of there, but the 3 has to stay under there. So there's my value for x, 100 root 3. Now I'm simply going to solve for dh dt. dh dt must equal 1,000, 10 times 100, square roots of 3 over 200. So 10 divided by 2 is 5, root 3. And the units are feet per second. Ask in words, answer in words. The string must be let out at a rate. And I did get a positive value, so that just confirms my work should be correct. Must be let out at a rate of 5 root 3 feet per second. There we go. So hopefully you can see over and over and over again, the process is the same. The biggest secret is to make sure that you glean all the information you can from those words and model them as well as you can. That is the key to a successful related rates problem.